So in what way can we simplify this down so such that we produce the equation that is necessary? It says, hence show that the perimeter P in meters of the pool is given by this. Well, a couple of things to notice is that the A over X is out, and it's X over B we're multiplying by something in brackets here. So what we're going to do, I can see that there's 100 over X, and we needed as I described, an A over X. So perhaps the A is 100. And so from here you can see one of the first things I do is recognize that we have a something over X at the front. So I just bring that forward. Everything else I put into brackets, not for mathematical sake, but just to say that all of this needs to be considered as one block, because if you consider the question, there's an A over X, and then all of this is one block with something factorized out. So I'm just following the pattern of the problem, which is perhaps advantageous. Note that all of these are fractions, bar the 2x. So what I've decided to do, and this does not have to be done in this obvious manner, but instead of 2x, I'm going to do 2x over 1. So just to consider them all as fractions. Thence I'm going to make them all over 4. So this is, because this is the largest common denominator, or this is the largest denominator here, the 4. So I'm going to decide to make the pi x over 2 over 4. And so how do I do that? Quite simply, pi x over 2, I can write 2 pi x over 4 by multiplying the top and the bottom by 2. The 2x over 1, how do I make the 1 4? Well, times top and bottom by 4. I'll have the 2 times 4 is 8, and 1 times 4 is 4, so I have 8x over 4. Minus pi x over 4, I don't have to change, it's over 4. And this is minus root 3x over 2. Well, if I multiply both sides, or top and bottom by 2, this will be 2 root 3x. Times 2 times 2, which will be 4. So what I've done is, number 1, I made them all fractions, and number 2, I made them all the same denominator. By doing that, they all have something in common. The 4 they have in common. But most importantly, just to note, they all also have x in common. There's an x here, an x there, an x here, and an x there. Factorizing out, therefore, since they all have it in common, x divided by 4. So if I take out x over 4 from here, I'd be left with an 8, which is the same 8 that I have there. So if I took out 8, x over 4 from that, I'd be left with an 8. If I take out x over 4 from this, I'd be left with 2 pi, because there is only 2 pi left in there. Take out x over 4 from there, of course I'd have minus pi, which is what's depicted here. And finally, if I take out x over 4 from here, I'd have only 2 root 3, which is what is there. So therefore, x over 4 is what is left. It's taken out. And left with 8 plus 2 pi minus pi. 2 pi minus pi, of course, is just pi, minus 2 root 3. And what we can find, therefore, is our final solution. This should perhaps say, therefore, as 100 over x plus x over 4, 8, plus pi minus 2 root 3. So we can get, therefore, a couple of things we can state. The main thing we need to state as a result of this is that we're aware that A is equal to 100. That's the first thing. We can see that the B is what we factorized out. B was equal to 4, as that is how we came to this 8 plus pi minus 2 root 3, which is what 8 plus pi minus 2 root 3 there. And it says where A, B, and C are integers to be found, C, root C, well, root C must be root 3. And so finally we can say, and finally C is equal to root 3, the square root of 3 there. And so therefore we have the solution to this problem. Thanks for your time.